Right. Yeah. Thanks for the introduction. Yeah, I'm really glad to be here and have a chance to talk about this stuff. So normally I present like some of the research work we do, but today I wanted to do something a bit different. So I am going to talk about some of the tools, ideas that I found useful over the last few years while working on various projects. I didn't assume any background, so maybe some of these things are obvious, but also like if there are some parts which are not clear or you want to know more about, you can always pause me, just say something and ask a question. Um, so I split it into three parts, and I'll also like do a break in between each part for if there are any questions there. So it's about reading, writing, and reviewing. Let's start then. Yeah. So directly, the first thing is like if you want to do reading for research, you need to know what to read. Um, the I think quickest way to get started is if you don't have a paper you want to read yet, you can find things by using keywords. So Google Scholar has a search function, and you can use keyword based search to get papers on a particular topic. So here I have an example. You type in the topic, you get the papers. And the nice thing about most of like computer science, at least fields like computer graphics, robotics, and computer vision, is that many papers are open access. So that means you can directly access the PDF from Google Scholar. If you already have a paper, like rather than doing a keyword search, there's a much more powerful strategy. You can do forward and backward search from your paper. So the paper from the previous slide, one of them would have this link here, which says cited by and a number. If you click on this link, you will see all the newer papers that cite this paper. And you can also sort these newer papers. So you can sort them by relevance, date, or citation. So it's very useful to find good papers by first choosing one you like, seeing through this forward search newer papers, and sort of filtering them. So you can filter for a certain time range, so only papers from 2022 or 2023, and sort them. The other, probably the most well-known way of finding papers is through backward search. What this means is when you read the paper, you look at the related work section. This is taken from that same paper I've been showing in the previous slides. There are citations here, and you can look up in Google Scholar again the name of the title of this paper, which you found cited in the related work. A good related work section also gives a nice story about all the papers in the field. So it helps you decide also what to read directly by looking at what the authors of this paper say about the older work. Yeah. One very useful idea is that rather than only searching for papers, it also helps to track the people in that field or that topic. This is a personal website. This is my personal website, but most researchers have a personal website. And on this, they usually list all their work, which is often related to the paper you were already reading from that author. So there are also lots of useful links in these pages to other materials besides just the paper. And I found that it can be a very nice way to pick papers to read, especially for older ones. If you really want to go deeper and do a very deep study of all the papers on a topic, there's specialized tools. This is one called Connected Papers, which I find quite useful. It uses language models, and the reference counts, so how many times papers were cited by other papers, to build a graph where all the connected nodes on the graph are papers that cite one or the other. It shows the time and it shows by the size of the bubble sort of how influential that paper was, how many citations it had. So you can use this to get like a full list and lots of additional tools to really do a deep survey if you're interested in getting deep into a topic.
So, Kashav, I have a question. So, what is the meaning of the circle size? So, it's the inference. It means the inference.
It means the number of citations, basically.
And the edges. That means they cite other, they refer to other papers, right?
Yeah, the edge means either like one end of the thing cites the other or that cites the other. So it's like a one-way connection in terms of one of them citing the other one.
Oh, and I think this fading effect is really nice. It's it also specify the time, right?
Yeah. So it helps to know which are the old but very well cited papers. Like for example, this one here is one of the first papers in this topic because it's very light but very big. And then there are some very recent papers which look very dark. And both these kind of papers are quite interesting usually.
And maybe what? So, is there any meaning of the edge distance?
So that is the embedding of these papers is calculated based on some language model which generates features of the paper, either of the abstract or the PDF. So the distances being close means the language model thinks these papers are more similar.
Oh, got it. Thank you.
Anything else about this? Okay, I go ahead then. So we saw how to find a paper and how to find many papers. But obviously, like a big question is like, is this paper worth reading once you've opened it? And I think this is actually quite challenging to develop a sense of whether a paper is worth reading. So you actually need to invest time to first even decide whether it's worth reading a paper. What I mean by that is because you can't read all the papers in depth, and there are so many papers in computer science, it makes sense to read them part by part. So there is an abstract and teaser figure, which you will see on the very first page of the paper, which should be the first thing you read. I think there are websites which show this directly in the website, but it's also fine to just open up the paper and look at the first page. And I think this can give you a very first idea of what the topic is. That is one thing you decide by. The second is looking at the impact of the paper. So the size of the circle we saw in the previous visualization, or looking at the conference the paper was presented in, where conferences themselves have different impacts and different levels of quality. So you can use conference rankings. I mean, these are not great, but generally helpful if you don't have a good idea yet for what conferences are highly competitive in the field. And typically, the papers in these top conferences have higher quality because they accept a very small percentage of the submissions. Another way to filter which papers to read is by the state of the art, so the performance. So obviously, like if you're in a kind of applied research field, like what I am in, vision and robotics, also for graphics, a good method should perform well. Typically, there are these benchmarks which have been established in our community as a way to measure progress over time on a particular task. So this is a benchmark I work on. It's called the Carla leaderboard. This is a autonomous driving benchmark. But what's important is that I want to just show that these benchmarks have some score, some ranking of the methods. And normally when you click on the URL of any method on these benchmark websites, there is often a also link there to the paper and code of that submission. So again, it helps to be aware of the top entries or the most influential entries in these benchmarks. The other thing that is the topic-wise filtering, which I mentioned in the beginning. It helps to, if you have a bit more time, not just directly filter based on the abstract and the teaser figure and these other factors, but also do a quick skim read of the entire paper. So basically the main point here is that linearly reading a paper from the beginning to the end is generally not a good strategy unless you are already very sure that you need to read this paper. So if you know 100% that this paper is important, then it is fine to read the whole thing in the order it's presented. But if you want to read it quickly to also help decide whether to read in more depth later, there are 4 things which I found most useful. You do the abstract and teaser figure, as we talked about before. But then there's also a section called contributions, which is typically written at the end of the introduction before the related work, where the authors try to write in very concise bullet points what is the added value of this paper compared to other papers on the same topic. And this gives often a very good idea of whether what type of paper this is and how hard it would be to read. And it also helps to find the key result of the paper. So look at all the tables and plots and see if there's a big gap between what this paper proposes compared to some other papers that they use for comparisons. So the basic idea is you do this quick read over these things, decide whether you want to read more. While doing this, you can take notes. I'll talk about that in a minute. And if you decide it's worth reading, you can go into further depth, which I think to understand a paper in depth takes, like, depending on how familiar you are with the concepts, from 2 hours to like many hours. It can take 4 or 5 hours if you need to look up a lot of background. So about the notes I mentioned, the way to take notes is like ideally directly annotating in the PDF. It does help if you are used to other tools to maybe write a summary separately. But to me, the quick way is always to use a PDF annotation tool and do highlighting and commenting in the PDF. So there are offline tools like Ocular, which is open source, and Acrobat. There's also online PDF annotation and organization tools like Mendeley. That's the one I use. So you want to do a bunch of things. You want to highlight important lines. Here I'm showing one example paper which I read, and I've shown what I use as a way of highlighting. So the first 2, like, I use different colors to make it more obvious why I'm highlighting certain parts. I think the most important color for me is blue, where I mark the important sentences in the paper, where if I had to read the paper again, I can look at everything marked in blue so that I can understand it quicker. This is usually like some of the design choices the descriptions of the models, and the main results. I also mark things that I find interesting in green. This are not necessarily important to understand the paper if I read it again, but maybe they wrote something in a very clear way and I want to remember that, or they had an interesting idea which they didn't study in this paper but may be useful for future papers. Then I mark things which I didn't immediately understand in yellow. So these are what I call the confusing parts. So maybe I understand them later, and then I add a little note, which I talk about in a bit, saying like what this actually means after reading the rest of the paper. And finally, I also have a red marking for maybe suspicious is the wrong word, but things which I don't agree with or I think need more evidence than what is presented in this paper. So maybe they say, oh, their method is the best at everything. But actually, you see later that it's not good at one particular metric on one task. So then I mark these points in red and also add notes of what exactly I mean by that. So yeah, these little blobs on the side are inline notes, which I add with Mendeley. But I think like almost any PDF annotator has these basic functions, highlighting and adding notes. And in particular, I find this color scheme idea to have helped me much more when I look at the draft again after taking the notes. So some things that are important while you read. You should look up unknown concepts. So again, there's an example from the same paper. I see that they mention something called linear quadratic regulator. Probably like if this is a new field to you, you might not know what a linear quadratic regulator is, which means you should look up the definition of this, which you might find online or at other sources. Sometimes the paper will cite prior work and not really go into details about the prior work. So again, this is the same paper, which says we employ trajectron plus plus. That's the name of another paper. And then that means if you don't fully understand the method based on this short one paragraph description, you need to go look up the original paper and read that as well. So I think, was there a question? I heard something.
So nowadays, there's a ChatGPT. So, which way do you recommend? Google just use, just read the definition written on Wikipedia, or just asking the unknown idea to ChatGPT. Yeah.
Yeah, I think there's some tools like ChatPDF, which I think is actually better right now. The problem is sometimes it outputs something completely wrong. Most of the time, it outputs something that saves you a lot of time. So, what I would do is like use the GPT style tools for when you're reading more quickly. But if you are spending more time and reading in detail, then look up the original sources online as well.
Then my question is, so for unknown field, actually, we don't know, we cannot make a good decision whether it is, true or not. So for that, how do you, how do you overcome that kind of ChatGPT problem?
Yeah, so basically, that's why I would say like rather than depending on your like knowledge for making this choice for an unknown field, just do it depending on how much time you have. Like if you have more time and you decide that you're spending more time on the paper, then it always makes sense to look up the old way. But when you're doing it fast, I think like these GPTs are good enough that you get something reasonable. And when they are wrong, sometimes even without much knowledge, you can identify that it's wrong. It's just copying something from some other paragraph in the paper, which is not very helpful. So then it's not too difficult, basically, or too bad to rely on this potentially wrong output. But I think all of these things are changing very fast. So probably like in the next 6 months, this advice will also be outdated and you need to do something else for this use of these AI tools.
Yeah, actually, I really like the old way because they are, um, uh,
Yeah. Okay, another quick point. This is the last point on reading. Besides reading the paper, you should also use project pages. So yeah, this is an example project page. They contain a lot of things. They contain slides, they contain videos, often with narration from the authors or some key results. They contain code, maybe a blog post. All of these things let you understand a paper quicker. So, especially when you have less time, an alternative to doing this 10-minute read of these four things, which I showed earlier, is to look at various links on the project page. And this can be more useful to get a quick understanding of a paper. I've linked also a thread to a lot of tips, which like there's a professor who creates a lot of these tip threads in Twitter. And I thought the one about reading was particularly useful. So what I'll do is after this talk is done, I'll send a handout of these slides and you can share them so that you have access to this link if you're interested. All right, so that was the end of the reading part. Maybe I'll quickly pause if there are any questions there before moving on. Yeah, we can also talk about any questions at the very end if you think about it later. So now I would switch to writing. This is actually one of my favorite parts of doing research. This is also something that is changing quite a bit with the new tools and so on. But I'll present some ideas which are the old school way, but I think still very useful now with all the new tools. So yeah, very first, like we write scientific documents, reports, papers, theses, things like this. And I think the standard in our community is to use LaTeX for this, LaTeX or LaTeX. It really helps you organize, style your paper in a consistent way. And I think like it's used very broadly. So the tool which I like for LaTeX is Overleaf. This is a online version of this software where you don't need to install anything and anyone can use it for free. So it's really good for beginners, especially because you get nice documentation on how to learn all the basics, lots of resources, and it's all on the Overleaf Learn website. So I think like you it's quite easy to learn. You write your paper normally, but you have commands for different things like inserting figures, captions, and so on. But it becomes very powerful once you get good at it. Actually, like this whole slide deck is also made in LaTeX, just a side point. Okay, so now that we're done with the tools, I think the most important rule of writing is to start early. Writing needs a lot of time. Iterative writing is, in my experience, always better than trying to write final polished text in one shot. So, because what ends up happening is when you write, you learn a lot about your research. You get new ideas when you write because you see that there is an obvious hole in the story missing. You see new problems when you write. Maybe you see that you don't have the right baseline or you don't have the right motivation for a certain concept that you're using in your work. And so, like, starting the writing part of any project early can be very helpful also in structuring the project itself. So start early, and then there's a flow which I like to go with. I first write everything I want to write as bullet points. So even if it's like an 8-page paper, I just write nearly 8 pages of bullet points first so that I roughly know that everything through all the sections is going to be consistent with each other. And I think it helps to do this in one sitting. So you really have a reasonable consistency from top to bottom by having all the section headings and some bullet points under each one of what needs to be achieved in that block of text. Then I go block by block. Usually I do this from back to front. So I start with the results, which is usually at the end of the paper, then go to the method, then the related work and the introduction. This is flexible. This you can like really do depending on, like, obviously it's hard to write results if you don't yet have results for your project. But the second step is this, what I call long text. I take the bullet points I have and just write them out in plain text in English, which doesn't need to be very polished, doesn't need to be very short, but just converts this into some text format. And then the final step, again, which I do like usually from the end to the beginning, but also you can vary, is improving the quality of that long text that you wrote. What helps in this final step is to get feedback. Like once you have some mix of long text and concise text, okay, there can also still be some bullets, but basically once you start having some concise text in the overall draft, it's super helpful to get feedback from others. This doesn't need to be your supervisor. It can be like your collaborator on the project. It can be like someone else who's interested in your work. Usually the feedback identifies some things that to you are quite obvious because you are writing the paper, but to a reader is not very obvious. And this helps you decide where to allocate more time in the writing process. I will quickly cover the structure of papers in robotics and vision. I'll do it a bit quickly because I think we have other topics that are interesting to discuss. And if I share these slides, you can always look at the slide later. So we have an abstract, which typically I consider to have 4 things, which each of these 4 things you can write in 1 to 3 sentences. So overall, the abstract should be 200 to 400 words. So you talk about the task, so the problem that this paper is working on, the challenge, so why is this not trivial or why was this not done before, the key idea, so what was done in this paper, and the key result. So either quantitatively in terms of, okay, we improve on this task by this much percent, or qualitatively that we can now do this behavior which was not possible before. The introduction, which I think is maybe one of the most important sections of the paper, especially for whether it gets accepted or not. So the introduction is where reviewers make up their mind almost all the time about whether they like a paper or not. Also where someone reading the paper. So when we think about the reading section, I mentioned that you should look at the abstract and the contributions in the introduction and the teaser figure. So a lot of the people who are only spending 10 minutes on your paper are only reading the abstract and the introduction. So it's a very important section because of that. You include the definition, which is kind of the same thing as the task in the abstract, but in a bit more depth. The motivation, which is why this problem is interesting. Why should we care about it? Who cares about it and why, basically? And the contributions, the thing which we talked about also in reading. So what's possible because of this work? Why was this not possible before? And this doesn't need to explicitly be written in the contributions. So the contributions is really short, but the rest of the introduction should make the contributions clear. That's one of the main goals of the introduction, to make it clear that each of your contributions is actually something that you did, it's new, and is actually something useful. The related work, I think you can structure in different ways. It's good to typically organize the different topics and cluster them so that you have similar things together. Or it's even possible sometimes to go over the related work chronologically, so like from early to more recent. But what's very important in the related work section is to very carefully say what is different between your work and the closest related work. Then there is the method. This is a description of your system. You actually spend a lot of the pages in your draft on the method because you want to make it very clear. And then finally, there's the results. Basically, talking about the experiments you did, what works, what doesn't work, and very importantly, giving some intuition or explanation as to why things worked or didn't work. Yeah, there's also a conclusion. There you kind of summarize what should have been learned. The conclusion often looks quite similar to the abstract or the contributions, but written in a different way, where you say, okay, now we showed all these things, rather than where in the initial stage where you say, we are going to show some of these things. You also talk about limitations. I think this is very important and not done enough in current papers, but really good papers are open about their limitations, and you normally put this in the conclusion and what future work there is. So some points about the method, which I think are important. Like, I think there's a sort of tendency for people to like putting in a lot of equations and math in papers. But my opinion on this is that you should only use equations when it's appropriate. So you shouldn't use equations for the sake of it, but you should use it when it actually removes ambiguity, when it makes something complex, easy to understand, and very precise, so that there is no way to interpret wrongly what the explanation means. When you use math, it's very important to introduce all the symbols you are using, provide some intuitions, so not just write a bunch of equations, and be precise. So like, don't introduce unnecessary symbols, and spend some time actually simplifying the equations. Often you can take a big block of 4 equations, and with the right structure and using the right renaming of certain terms, make it much more concise. Another point which I think is very important is that redundancy is fine for the key concepts in your papers. So what I mean is, just because you wrote an equation about a certain concept in your paper, that doesn't mean you shouldn't write about it in text or in the figures. It's often quite good to have a combination of an equation and a figure, or equation and text, or figure and text, especially for the most important or difficult concepts that you have put into your paper. All right, so about figures quickly. I think these are some stylistic recommendations. Usually it's nicer to put figures outside the text so that they don't break the flow of text. And also, for someone reading quickly, they can directly look at the figures of your paper because they're clearly seen at the top of each page. It's very important, especially for people who read on print, to make sure that the font size in your figures matches the font size of the text. So usually the text font size is chosen to be readable when printed. So it helps to have font in your figures be the same size. One of the important parts of a figure is the caption. So in the figure, you should have everything that is shown in the illustration also described in the caption in a way that the figure alone can be understood as a standalone part of your paper. This is especially useful for the main methodology figure. So these are very complicated usually. And if you exclude details from the caption, which are only available in the main written text, it makes it harder for someone reading your paper quickly to understand your method. Instead, if you put the complete description of the figure in the caption, even if the caption is quite long, there are like 4 or 5 line captions sometimes in our field. This helps the quick reader understand your paper better. And in the long term, this is very helpful because I think your paper will have many more quick readers than in-depth readers most of the time. You can use figures and tables from other sources. So if somebody else already made a very good figure to illustrate a concept, it's totally fine to use that figure again, as long as you cite the source of that figure in the caption. I think this is an idea that's not used that often, but can be very helpful and saves a lot of time even when you're writing, if you do it in the right way. It's important that you talk about your figures in the text. So if you include a figure in the paper, you should refer to that figure somewhere in the textual story, because the full reader who reads the whole thing top to bottom will focus on the text and look at the figure when you say figure 2 or figure 3 in the text. So then it's important that every figure is actually referenced somewhere in the text so that someone reading through the text doesn't skip figures. And when you do this, you can reference the same figure many times. So it is not necessary that if you have 5 figures, you mention each figure only one time in the written text. Right. Another small stylistic thing, I think it's really good to minimize white space. So if you have plots that don't need the full width of your page, it can help to stack them side by side. And this is a general rule for figures and tables. How do I make figures? There are lots of ways to do it, but I think one tool or one set of tools that are very helpful for these academic papers is vector graphics programs. They make it such that your illustrations can be scaled up or scaled down without losing quality. And it also very easily lets you add annotations, like adding equations in your figures or adding text in your figures, symbols, and so on. So Inkscape is a nice open source vector graphics editor, and there's an extension called TextText that lets you type equations and symbols inside the vector graphics tools. Yeah. Now, another interesting point. It's important to follow good scientific practice while writing. So in our field, you always write in your own words. So that means you should not copy sentences directly from the source, even if it is written very nicely in the source and you want to say the exact same thing. You should try to rewrite it. So that doesn't mean you should not use the style and the structure that papers you read have. So it's very good to be inspired by the papers you read and use similar style and wording. It's just not a good idea to directly copy text from one paper to another. And yeah, once you've done your concise text, you can use tools like Grammarly for fixing typos. I have actually found that ChatGPT is a really good grammar checker, much better than Grammarly, with the right prompt. You can find these prompts anywhere these days. But you should use AI writing tools, in my opinion, for this like final phase of editing. But be careful that you have explicit permission to do this. So some conferences have policies, or some, like maybe if you're writing a report for your um, bachelor course or master course, maybe you're writing your thesis, there may be an explicit policy banning the use of these language tools for doing this editing. Make sure you don't have any such permission problems if you want to use these. And also, like, I really recommend using them for the final step of cleaning up the text once you've done everything else, and not for generating the text itself. They are much better at retaining the meaning and structure if you already have good text and you only ask them to change the style. So I think this is my final point on the writing side. So you should cite everything relevant in your writing. So often you say some facts that, okay, X is a very important problem. It's important then to add some citations that provide support for these sort of like facts or claims. The other thing is that it's very helpful to cite a lot of the work, because this builds the right connectivity for your paper in these search tools. The more you cite, the more papers get linked to your paper. So this doesn't mean you should cite completely irrelevant things, but I think you should not be stingy in citing only the most related work, but whenever possible, cite everything that is relevant. Minor point is that citations come before punctuation, so you put the full stop after the reference. And there are nice LaTeX tools for doing the citations. So there's something called BibTeX and the cite package that lets you, with minimum effort, manage all the citations in your paper. Okay, yeah, so that was the end of the writing part. I would pause for some questions, and yeah, also maybe check how much time we have for the rest and whether we should just have a discussion or continue with the last part.
혹시 학생분들 중에 질문 없으신가요? 네.
Can you say that again?
So I just ask students whether they have a question or not, but it seems like they don't have question. So I think this is really valuable, information for students, right? In order to write a really good scientific paper, right?
Yep.
Yes. And 네, 질문하세요.
Okay.
Someone tried to ask some question, but I don't know who. Yeah.
So I'll just.
Yeah, sorry. Yeah. I think we have 20 minutes, or I think you can spend more time than 20 minutes. So it's up to you. So don't.
All right. Yeah. Then I finished the last part as well on reviewing. All right. So what is a review, first of all? So I'm going to try to convince you that reviewing is something relevant to you. So I first talk about the basics. So reviews are documents that are like maybe one page, few paragraphs long, that judge if a paper submitted to a conference or journal gets accepted. Normally, these papers have 3 to 5 reviews each from different reviewers, and there is some structure above the reviewers that helps decide the outcome of a paper submission. There's some area chairs, program chairs, associate editors. It's not important, but some people basically read these reviews and then decide whether to accept a paper or not. As I mentioned a bit earlier, some of the top conferences and journals have very competitive acceptance rates, like 25% or less. So it's actually quite crucial, these reviews, because they decide whether your paper gets accepted or not. And it's quite hard to get accepted if you just look at the statistics. There's this concept called double blind and single blind. Most often in our community, the authors and reviewers don't know each other. So the original submission removes all the author names. And similarly, the authors don't see the reviewer names when they get the review. But there's another common practice, especially for some journals, where you can see the author's name as a reviewer, but the author still can't see the reviewers' names. So these are proposed for various reasons. I won't get them into them in detail, but I think it's just good to mention for completeness. So the first question, why not accept all papers? Why accept only 25% of the papers? I think this is like an important point to clarify. So papers can have a negative impact. If you simply accept everything that's submitted, some things can happen, such as papers with wrong or fraudulent results can cause damage to the conference and the field. So it can mislead the researchers thinking that these results are correct and some ideas are good when they are not. And if the paper uses difficult or misleading evaluation settings, it then makes it harder to follow up on that paper. Maybe this paper does some wrong practice while evaluating, but then follow-up work needs to compete with this wrong practice, and it gets killed. Like it kills basically progress in the field by sort of doing something unusual and not explicitly mentioning it. So it's important that you only accept papers that follow standardized evaluation or evaluation that can be built upon. Also can create bad precedent if you accept bad papers. It creates this impression that because this bad paper was accepted, this other bad paper should also be accepted, which is not what we want for the field as a whole. And the other more practical point is just if there are too many papers, it wastes everyone's time. So the people who need to review them, who need to read them, basically it creates fatigue and overwork for the whole research community if you just accept all papers to all conferences. So the second thing is, why should you as a student now care about reviewing? I think like, to me, this is all like actually a very interesting perspective on research. I think reviewing is the perfect mix of reading and writing. It helps you very easily build skills in both reading and writing with a well-defined task that requires good reading and good writing. So to be more specific, some things that like I found for myself got much better as I reviewed papers over time, and I reviewed many papers, is some of the critical thinking, like when you're reading and writing, making sure that like there are no flaws in the arguments, taking notes. So you can take more notes that are to the point and actually useful when you look at the note again, like a month later. The writing style, so you become better at writing with more information and less space. And also structuring. You get better at what should come before and what should come afterwards in an argument. Besides this, like the first bullet where I just think it's like good to develop skills to do reviewing, you actually may be invited to review in the future. So if you stay in the research community, if you do a PhD, become a professor, you will be asked to review for conferences, and then like knowing about how to review is a very important skill at that point. All right. Yeah, hopefully you're convinced that this topic is interesting. So now I'll tell you a little bit about what to do while reviewing. The very first step is to read the review guidelines. This is kind of obvious, but not everyone does it. People often review any content the exact same way, which I think is wrong. Every conference has specific review guidelines and review criteria, which I think should be the first thing you do when you're reviewing is look at these guidelines to make sure your review is in line with these guidelines. So as an example, there is this conference called TMLR, and for this, the guidelines are whether the claims are supported by accurate evidence and whether some individuals would be interested in the findings. They also give like very detailed descriptions further of both of these points. But basically what this means is that you cannot reject a TMLR paper because it has bad results, for example. This is not a reason to reject the paper. You would need to reject it because the audience would not be interested given the bad results. So the logic needs to be followed via these guidelines, basically, when you're reviewing. CVPR, ICCV, these are other conferences. They have actually similar guidelines, but they introduce some more points like CVPR, ICCV community standards. So you need to understand what this means, and there's descriptions on this. So I think in general, yeah, first step is like when you're writing a review, read the guidelines. What are the like key points, like the shortest summary of what you need to do in a review? So you need to provide feedback to the authors. So the first consumer of your review is the author. And this feedback should include multiple aspects of the paper, not just one thing. You talk about the language, the clarity, the rigor. So that means like whether the settings were all correct and the experiments were meaningful. The references, if something is missed or something is not so relevant, and the experiments. There's also this very subjective notion of novelty, which I don't really like, but is also kind of important to measure when you're providing feedback to the authors. The second user of your review is the AC or the area chair, the people who decide whether to accept or reject the paper. So it's important that in your review, while you're providing feedback to the authors, you're also providing a recommendation and reasoning to the area chair for whether to accept or reject the paper. And sort of the final goal of both of these things is that like you want the paper to get better as a result of the review. So it helps to make concrete suggestions saying like do this rather than saying this is good and this is bad and ending at that. Yeah, so what I just kind of hinted at is that reviews need to like you need to try to be unbiased and objective and state both positives and negatives of what you're reading. What this means is that you can be biased, like maybe there's a topic you like or an idea you like, which generally makes you favor this when you're reviewing, but be aware of this and try to be objective to the best of your ability. And one thing which I really found useful is that after writing the entire review, try to review it like the review you've written from the perspective of the author and the area chair. So if I am an author and I read this review, what can I do? what can I understand from it, what can I implement, what do I have enough time to answer, and what is impossible. Similarly, like if I'm an area chair, I read this review. Do I understand that the reviewer got all the concepts in the paper? And do I have a clear way of deciding whether to accept or reject the paper? So think of the final review from the perspective of the people who are going to use the review before submitting it. So the general structure, I will go over this very quickly because this changes based on the guidelines. But for most conferences, you first summarize the paper, and this is mainly for the area chair to know that you understood the paper and trust your review. It's also kind of for the authors to understand how well you know the topic. You show the strengths. This is mainly for the area chair to decide whether to accept the paper, but it also helps the authors a little bit to know what the reviewer liked and what they should continue working on in future work. The weaknesses, this is the most important, I think, part of the review because it's very important to both the area chair and the authors. The authors will read the weaknesses and try to argue that they can do better, and this is not a reason for rejection. And the area chair will use the weaknesses to decide what to do with the paper. So then finally, you summarize everything. This is just for the area chair. You provide a score. Generally, there are scales like 0 to 5 or weak accept, weak reject. You basically quantify your impression and you say why, because of these strengths and weaknesses, which are the most important strengths, which are the most important weaknesses that you considered. And finally, you can give comments that are not related to the acceptance decision of the paper, but just suggestions to improve the quality of the paper. Maybe typos, maybe suggesting other experiments that are not necessary for accepting the paper, but you think would make the paper better.
So, Kashyap, this is for me.
Why is it for you?
Because I'm leaving some papers. Thank you.
The slightly interesting point, I think, is that different papers need different kinds of results and reviews. So if you're reviewing a paper that just takes a very well-known problem in the field and has an idea which makes sense, then just showing that it gets better on a benchmark is enough. But if the paper proposes something weird or something you don't understand, then you actually need to be very careful looking at the results. Maybe it needs like really extraordinary results to justify the claims made by this like weird and complex method. But on the other hand, if the idea is like something you think is very transformative, like they completely change the way a problem is done and it's a well motivated, good way to do this problem, then maybe you don't need these like standard established benchmark results, but a proof of concept that this idea has promise and it's worth for other people to now try to transfer this to the normal benchmarks. There's also some kinds of papers which are theory or position papers which don't have experiments at all. So it's important while reviewing to understand what kind of results are needed for the paper. Yeah, this is my final point on reviewing. Like I talked a lot about how to do it, but I think the best way to understand is to actually read reviews. So there's a website called Open Review, which for some conferences like iClear, PMLR, NeurIPS, actually publicly shows all the reviews of all the papers that were accepted, or sometimes even all the papers that were submitted. So Open Review is at this link, and it also has a search function, just like Google Scholar, where you can specifically look up papers and the reviews of these papers to get a better understanding of how reviews are written. So not all reviews on Open Review will be good, but I think it's also nice to look at bad reviews. This is something that you don't get enough exposure to. And when you read this review, you kind of make up your mind that, okay, I should not do this when I write a review. All right, so that was the final slide. I want to quickly mention that a lot of these slides were adapted from a stack of slides from my supervisor, Andreas Geiger. So a lot of credit to the slides goes to him. And also that I couldn't talk about some of the research we do. We work on self-driving, and I also think that's very cool. So if you're interested in some of our research on driving, I would recommend looking at this link, which is my website, which has all these papers and stuff which I mentioned earlier, project web pages, to help you read and learn more about this research. So yeah, I think this is it. I'm happy to take questions or discuss now, and I will share all the slides later in case you find them useful when you're doing some reading or writing in the future.